Hi guys, welcome once again to my YouTube channel. So in this video I'm going to be walking you through the 0x00 CLO World project. So the first thing we need to do before we do this project is to create the repository for the project in our GitHub account. Then we clone the repository in our terminal. So the name of the repository we are going to be creating is ALX low level programming. So let me copy the name from here. Then you go to your GitHub account. Then you click on new repository. So once you click on that, it's going to direct you to this page. So the next thing to do is to put the name. Just paste the name you have copied in the section for repository name. Then for the description, you can say this repo contains C programs. You can use any description you like. It's not necessary for you to use this. I'm just using this one. So after you've done that, there's no need to do anything again. Don't add the repo. Make sure it is public. Don't add the readme or git ignore. So you just scroll down, then you click on create repo. So now the repo has been created. Now the next thing for us to do is to clone the repo in our terminal. So let me go to my terminal, then I'll clone it. So the command to clone is, you all know this, git clone https:// then your personal access token. So let me copy my token here, then you paste it. After that, followed by at github.com/ my GitHub username / the name of the repository. The name of the repository is ALX low level programming. So I'll copy it from here and paste it here. Then .git. So you see, it says cloning into this. Warning, you appear to have cloned an empty repo. So if I hit ls and I press enter, you will see that ALX low level programming is now one of my files. So after cloning the repo in your terminal, the next thing to do is to cd into it and create your first readme. So let me cd into it. So cd ALX low level programming. Then let's create our readme. So I can say echo, then the text. You can use the name of the repo as the readme text. It doesn't matter. They did not specify what you should use as a text, so you can use anything. So greater than readme.md. So this means insert this ALX low level programming text into the readme file. So if I hit enter and I hit ls, you should see that now I have my first readme created. So the next thing to do is to now create our first directory in that repo that we have just cloned. The name of the directory is 0x00 world. So I will also copy it from here. Then I'll go to my terminal. Then I will do mkdir, then the name of the directory, which is 0x00 world. So if I hit ls, no, it should be empty, so there's no need to hit ls. So I will cd into it. So cd oxol world. So now I'm in the oxol world directory. The next thing to do is to create another readme in this directory. So I'll say echo. So I can also use the directory name as the text. It doesn't matter. You can use any other thing you like, but I will be using the directory name as the text. So greater than readme.md. Now hit enter. So if I hit ls, you should see that in my hello world directory I have my first readme. So after doing this, we have completed the first step. So the next thing to do is to now start the project actually. So let's go to the first task. So task 0 says write a script that runs a C file through the preprocessor and save the result in another file. Right? They said the C file name will be saved in the variable this, and the output file should be saved in the file C. That means the name of the output file is C. You understand? So this is what we will do. Let's copy the name of the file that will contain the answer for the first task. So the name of the file is 0 preprocessor, so I'll just copy it. Then I'll go back to my terminal. Then I will create the file and open it in Vim. So to do that, you use Vim, then the name of the file, then hit enter. Now remember, since you're writing a script, your first line must always be your shebang. So I will hit I to enter insert mode. Then I'd say hashtag /bin/bash. Now the next thing is to now input my answer. So let me input the answer, then I will explain the answer to you. So the answer is GCC. Then we use the -e flag. Then the name of the source code file. The name of the source code file is $C file. Copy. Then let me paste it here. Then -o flag. Then the name of the output file. The name of the output file is C, small letter C. So we just add C. So that's all. That is the answer. So let me now explain the answer. Let's go back to the question. They say write a script that runs a C file through the preprocessor and save the result into another file. Now, what is a preprocessor? A preprocessor is part of your compiler that carries out one or two tasks before your compiler compiles your C source code. Your C source code is your C program. The C program that you write is known as your source code. So the preprocessor is part of the compiler that does preparatory tasks for your compiler before the compiler compiles your code. It does two specific things actually. The first thing it does is it removes comments from your code. What are comments? A comment is a line of text that doesn't get executed when your program is being run, that is used to document your code or describe what your code is doing. As a programmer, a very good habit that you should have is the ability to always document your code, because document your code makes it easier for somebody else to understand what your code or your program is doing. So that is the first thing the preprocessor does. It removes comments from the code. The second thing is it adds the necessary header files to your code before your code is being compiled. I will not tell you what header files is just yet. I will explain what header files is later in the task, but just note those two things. Number one, it removes comments. Number two, it includes header files in the code before the code is being compiled. So let's now go back to the answer. Let me explain the answer. So for you to compile a program, you need to use the GCC command. What does it mean to compile a program? To compile a program means you convert the program from human readable language to machine language. Your computer does not understand human language. You understand? It only understands ones and zeros. So that is the job of your compiler. The job of your compiler is to take the code, analyze the code line by line for errors. If there are no errors, it will generate an object code. The object code is the language that your computer understands. If in the process of compiling the code it encounters an error, it is not going to create an object code. It will stop compiling and tell you that there's an error in your code, that you should correct it. So the command to compile, the general command to compile is GCC, followed by the name of your source code. Do you understand? Now, they said in the question, we should write a script that runs the C file through the preprocessor and save the result in another file. That means that write a script that only preprocesses a C file but does not compile. If you want to only preprocess a C file and you don't want to compile the C file, the correct flag to use is this -e. You will combine this -e flag with this GCC command. So once your machine sees GCC -e, it knows that okay, this person only wants to preprocess, it doesn't want to compile. Now you will just say GCC -e, then the name of your source code. In this case, now the name of our source code is what? Is this $C file. Do you understand? Now, the preprocessed source code is going to be saved in another file. The name of that file is C. Now, what this -o flag is, it means that okay, after you have already preprocessed the code using this part of the command, save the preprocessed code in this C file. That's why I'm including this -o flag. The -o flag says save the object. The O is for object. Save the object code in the C file. So after you have written these 2 lines of code, that is all for task 1. So the next thing to do is to save and exit. So you just hit escape, then capital letter Z twice. So after doing that, now since you are writing a script, you need to make the script executable. So you say chmod +x, then the name of the script. The name of the script is 0 preprocessor. So you copy it, then you paste it, then you hit enter. So if I hit ls, you will see that my script is now executable. So the next thing to do is to git add, commit, and push. So git add dot git commit -m, then the name of your commit message. I will always use the name of the script or the name of the file as my commit message. Then I will now git push. Okay, so my code has pushed. So let's go to the intranet and check if what we have done is correct. So as you can see now, the code checks. So we are done with task 0. So the next one is task 1 now. So let's go to task 1. So for task 1, they say write a script that compiles a C file but does not link. That means that you will compile but you will not link. I will explain what linking is. They said the C file will be saved in the variable this, just as before, in this variable name. The output file should be named the same as the C file, but with the extension .o instead of .c. Say example, if the C file is main.c, the output file should be main.o. The same name, main, but different extension. One is .c, one is .o. So let's do that. So let's first copy the name of the script. So the name of the script is one compiler. So I'll copy it. Then go to my terminal. Then let me clear the screen to have room to work. Then I will do vim, then paste the name of the script. So you can see the name of the script has been created and it has been opened in command mode in vim. So the next thing to do is to go into insert mode by pressing I. So after doing that, I can now input my code. So remember, if you are writing a script, the first line should always be your shebang. So hash !bin /bash. So the next line will be our code. So the answer to this is gcc, then the flag is -c, then the name of the source file. The name of the source file is this $, then C file. So I will just copy this, then I'll paste it. So let me just paste it. Let me explain what is going on here. So this is what is going on. The gcc command compiles the code, right? But this -c option will only create an object code. It will not link. What does it mean to link? Linking means combining the object code with the required libraries. So sometimes when you write a C program, you use some functions like printf, putchar, and so on and so forth. This printf, puts, and putchar function, they are generally used to output or to print something to the screen. Now, if you want to use those functions to print something on the screen, you must include the header files where those functions belong, right? Now, those files, they belong to a library. You understand? Now, what your linker does, or what link means is, at the linking stage of the compilation your linker will take your object code and combine it with the necessary libraries or the required libraries in the code. So the combination of object code plus required libraries is called linking. Do you understand? So if you run gcc then -c followed by the name of a source file, your compiler will only will create an object code, but the object code will not be executable. It will not create it will only create an object code, but it will not create an executable code. The creation of the object code, it stops at linking. Once your compiler takes the object code and it takes the required libraries and joins it together, it has linked. It will only link. That is the linking process. So it will not create an executable file that you can execute to see the output of the code. You understand? So in order for you to just link, you use the C flag in the GCC command. I hope you guys understand what I'm trying to explain. I know it might be a little bit confusing, but with time you will get the hang of it. So after this, you just hit escape to go into command mode. Then you save and exit. So capital letter Z twice. So the next thing for us to do is to make that particular script executable. So you say chmod +x, then the name of the script. The name of the script is one compiler, so you paste it. Oh, sorry. Let me copy it again. One compiler, so I'll copy it from here, then I'll paste it, and I'll hit enter. So if you hit ls, you should see your one compiler is executable. So the next thing to do is to git add, commit, and push. Then git push. So it has pushed. So now let's check the code and let's see if what we are doing is correct. Yeah, so as you can see, the task 1 checks, so we don't have any errors. So let's go to task 2 now. So task 2 says write a script that generates the assembly code of a C code and save it in an output file. The C file name will be saved in the variable C file. The output file should be named the same as the C file, but with the extension .s instead of .c. Example, if the C file is main.c, the output file should be main.s. So same name, different extension. So let's copy the name of the script. The name of the script is toAssembler. So I'll copy this. Then I'll go to my terminal. Then I'll do vim. Then paste the name of the script. Okay, so hit I to go into insert mode. Then put your shebang. Now the command to only create an assembly code. The command is gcc minus capital S, then the name of the source code. The name of the source code here is C file. So I'll paste it. So what this command means is that the gcc command, your compiler will only create, instead of it creating an executable code, it's going to create an assembly code instead. That is what this -s flag is for. Once you run the gcc command with the -s flag followed by the name of your source code, an assembly code will be generated, not an object code. An assembly code will be generated. So after typing this, you just hit escape, then you save and exit by pressing capital Z twice. So after doing that, you make the script executable by saying chmod +x followed by the name of the script. The name of the script is toAssembler. toAssembler. Let me copy it from here. So copy, then paste toAssembler. Then if you hit ls, you can see toAssembler is executable. So I will add, commit, and push. Then I can use the script name as the commit message. Then I git push. Okay, so it has pushed. So let me clear the screen. Then let's check the code. So as you can see, 2 assembler checks. There are no errors in our code. So the next thing to do is to go to task 3. So they say write a script that compiles a C file and creates an executable named C is fun. So this is what we do. Let's copy the name of the script. The name of the script is 3name. Right? So copy. Then let's go back to our terminal. Then vim followed by the name of the script, which is 3name. Then hit enter. Then go into insert mode by hitting high. So the next thing to do is to put your shebang. So /bin/bash. Then on the next line, we can put our answer. So they said write a script that compiles a C file and create an executable name C is fun. So this is what we do. The command to write the command to compile a file, right, and save the compiled code or object code in another file is this gcc, then followed by the name of the file you want to compile. The name of the file you want to compile is given to us here. This $C file. This $C file is name of the file. You copy it, then go back, paste it, then followed by the -O flag. So what the -O follow after the -O flag, then followed by the name of the file where you want to save your object code. Where you want to save the name of the file is C is fun. Yes, this is the name of the file where they ask us to keep our object code. So copy this, then go back, then paste it. Now this is what this command does. The gcc command will compile this C is fun, then create an executable file, right? Now naturally, if you want to compile a code or a C code, if you compile it by using just gcc followed by the name of the source code, it will create an executable file for you, but it will save it in a default file named a.out. But if you don't want it to save it in that default file, you can specify the name of the file you want the compiler to save it in. To specify the name of the file, use the -O flag, right? Then you specify the name of the file. The name of the file I want my compiler to save the object code is C is fun, so I will also include the name. So that is all. So after doing that, we save and exit. Now we make our script executable by using chmod +x. Then the name of the script. The name of the script is 3name. And I paste, then hit enter. So if you hit ALX, you can see that your 3name is now executable. So the next thing to do is to add, commit and push. Then git push. So it has pushed. So let's check our code. So as you can see, 3name checks, no errors. So the next thing to do is to move on to task 4. So task 4 says write a C program that print exactly this text. Programming is like building a multilingual puzzle followed by a new line. They say we should use the function puts. We should not use printf. So if you use printf, it will not check because they specifically told you not to use it. Your program should end with the value 0. So let's first copy the name of the script. The name of the script is for puts. So after copying the file name, we go back to our terminal, then we do vim, then the name of the file. Now since you are writing a C source code, you can see that the file name is ending with .c. We are not writing a script. So we don't need to start what's it called? We don't need to start the code with a shebang. Let me first type in the code, then I will explain everything the code is doing. So let me hit I to enter insert mode. So let me put in the code first, and I will give you an explanation. So I will explain what I'm doing in a moment. So just follow through with what I'm doing. Yeah, so we copy the text from the intranet, then we go to our term, then we paste it. Then they said it must end with a new line, so we put backslash n, we close the quotes, then close the parentheses, then terminate it. Then after that we return 0, then also terminate this, then we close the curly braces. Now let me explain this lines of code one by one. Now this first line, this place where you have hashtag include stdio.h, this hashtag include, if you see a line of code that starts with hashtag in C, that line of code is called a preprocessor. Remember I was explaining what a preprocessor is in task 0. I said a preprocessor is part of your compiler that does one or two things for the compiler before the compiler compiles your code. Now what this line is telling us is that it's telling your compiler to include the content of this file, this stdio.h file, in the code before the code gets compiled. It is telling it to include this in the code before the code is compiled. When time you see a file ending with the extension .h, it means that the file is a header file. Now this stdio stands for standard input output, and the stdio.h is the standard input output header file. Now in order for you to use functions like put, printf, scanf, putchar, and so on and so forth in your code, you need to include this standard input output header file. If you don't include this and you try to run the code, it's going to throw an error. You understand? All those functions, they are in this header file. So in order for you to use those functions, you need to first include it on the first line of your code. So this, from this part to this part, is documentation. This slash and the asterisk is used to document your code. Anything that comes in between this first slash and this asterisk and this last asterisk and slash is taken as a comment. Remember I told you that a comment is used to document your code, to describe what your code is doing. So this particular line, all these lines, they don't get executed when your code is being executed. Your compiler will just ignore all these comments. It doesn't have anything to do with it. Remember I told you what the processor does, that the processor removes comments. So at the point of compilation, your compiler will take all these things away from the source code before it compiles the code. Now the next part, this int main void, this is called a function. Now every C source code must always have a function. It can have more than one function. If it has only one function, that function must be the main function. The main function is the part of your program where all the statements to be executed must be placed in. Look at it. I want to execute this statement. Programming is like building a multilingual puzzle. If I'm going to execute it, I must put it in the main function. If I put it outside the main function, the compiler will throw an error. You understand? And this particular statement will not be executed. So the main function is the starting point of your program. It is where everything that is going to be executed in the program needs to be placed. If it is to be executed, it must be placed in the main function. Now the next part is the put. Now this put is a function. It is used to output something on the screen. If you want to print out a particular thing, you use the put function to do it. Now this is the syntax for the put function. You have put, then you open parentheses, then you put the text that you want to print out in double quotes. You can see at the beginning of the text I have a double quote followed by my text, followed by the new line character, then followed by the closing quote. So the text you want to print out must be in quotes. Do you understand? Now after that, you can see at the end of the put function I am having a semicolon. Now in C programming language, every statement must end with a semicolon. The semicolon is used to show that this is the end of the line, this is the end of the statement. The semicolon terminates the statement. It tells your compiler that this is the end of this particular line. Anything after this now will begin on the next line. Now look at this part. We have the return 0. Now remember what I said. I said that every statement that must be executed in the C program must be in the main function. Now this return 0 is used to return this value 0 to the main function. You understand? The reason why you are returning a value 0 to the main function is to tell the main function that all of the statements that are present in the main function has been successfully executed. Once your main function is seeing this 0, right, this 0 as a return value, the program terminates. That is the end of the program. So don't forget, all the statements that should be executed must be in the main function. After writing the header of the main function, that is this int main void, you open a curly brace, a left curly brace, you put all your statements, then you close the left curly brace with the right curly brace, as I've indicated, as I've done in this place. Now one more thing, this void means that the main function is not taking anything as an argument. Now let me define what a function is for you in C. A function is a routine that can take in more than one input and give out a single output. Now what this void means is main function is not taking an input, which is the void. Void means nothing, but it is returning an output, and the output it is returning is an integer. I hope you guys understand it, and you may not understand this now, but as you go on in the C programming language, all these things will become very clear. Now another very important thing is this: once you are writing your source code, please do not leave extra lines. Don't leave extra space. If you leave extra spaces, you are going to run your code through Betty. Me, I'm not going to run mine through Betty because I already know that I'm not supposed to leave extra space, or I'm not supposed to indent my code anyhow. What do I mean by indent my code anyhow? For example, if I do this, if I hit tab, for example, if I do this, if I hit the tab, you can see the indentation level is not the same. If I do this and I try to check and I run and I try to check the code, it's going to throw an error. Why? Because the indentation level is not aligned. So these are the key things you need to know. Don't leave extra spaces. Don't indent anyhow. When you want to comment, this is the style of commenting that you use. There is a Betty program that is used to check your code. If your code follows the Betty style and Betty documentation process. So if your code does not follow the Betty style and Betty documentation process, the checker will not check your code. So you need to know all that. So after writing my code like this now, the next thing for me to do is to save and exit. So I will just hit escape, then capital Z twice. So after writing my source code, the next thing to do is to compile my source code. Now this is how to compile. To compile, you use the GCC command. You say GCC followed by the name of your source code. The name of your source code is 4puts.c, right? So I will copy this from here, then I will paste it. Then now if I only run this command, right, it is going to compile the program 4puts.c. Then it will generate an executable file. The name of the executable file will be a.out, and the reason why it is going to give me my executable program in the a.out file is because I did not specify the name I wanted to save my executable file in. So let me hit enter. Let me show you. So if I hit enter, you see it has compiled. If you hit ls, you will see a.out. Can you see it? A.out. But I don't want my executable code to be named a.out. So that means that if I don't want it to be named a.out, I need to specify the name in the GCC command. So let me delete this a.out. Then I will show you how you can specify the name where you want your output code to be saved. So this is how you do it. You will just say GCC followed by the name of your source code, which is 4puts.c. Then you will use the -o flag. We have used it previously in task 3. So we use the -o flag, -o, followed by the name where you want your compiler to save your output code. So the name I want to use is just 4puts. You can use 4puts. 4puts is the name of your source code, but you will not use the extension .c. You understand? So this is what this command will do. It will compile this code, right, and save the output code in this file named 4puts. So if I hit enter and I hit ls, you can see I'm having 4puts. See my source code here, 4puts.c. Then I'm having my output as 4puts, right? Let me now run the output and you will see what will happen. So if I run 4puts, sorry, it should be 4puts. I type 8puts, sorry. So /4-puts. So you can see the string was printed. Programming is like building a multilingual puzzle. So that's how you do this particular task. So I'll clear the screen. Now you don't need to make your source code executable. All you need to do is just compile. After compiling, you can just git add and commit and push. So I'll git add, then git commit -m, then the name of the file 4puts can be your commit message .c. Then I'll git push. So it has pushed. So now let's check the code. Okay, so we are having one error. Let's see what the error is. See details. I think I know what the error is. I'm not supposed to use a new line character. Correct output. Okay, programming is like, oh sorry, that is not the issue. The issue is there. I'm supposed to include a quote before the programming, but you can see mine there is no quote. Okay, let's do that. So let me go back to my terminal. Then let me open the file again in vim 4puts.c. okay, so I am supposed to put a double quote here again. So let me just do that. So let me go into insert mode. Then to put a double quote, if I put the double quote like this, right, the program will not run because my compiler will not understand where the first double quote or where the second double quote starts or ends. So in order to use a double quote in this string, I need to escape this second double quote using the backslash. So I'll put a backslash here. So you can see it has been escaped. So after doing this, you can just save and exit. Now let us now rerun. Let us rerun. We will recompile the code. So to recompile, you say GCC followed by the name of the file, 4puts.c, then -0, then where we want the output file to be saved, that is 4puts, right? So I have recompiled. So let me now rerun the code again. So I will just say ./4puts. So you can see now when I run the code again, I am now having the double quotes in front. So that is how you do it. So let me git add, git commit, and git push again. Git add, git commit, then 4puts as my commit message, then git push. So the code should check now without any errors. So let's check the code now. Okay, so you click on start a new test. It's still failing that check. Let us see what the error is. It's not supposed to fail the check. So correct output. Programming is like building a multilingual puzzle. Okay. Like I said earlier, the new line character, I'm supposed to remove it. Okay, no problem. Let's remove the new line character, and I will explain why I can remove it. Now, this puts function, it will print out a string to the screen. Then it will also automatically print a new line by itself. So I am not supposed to put a new line character here. So let me remove it. This new line character, I am going to remove it. Yeah, so that's all. So let's save and exit. Okay, so you recompile again. Let me clear the screen. Then I'll recompile gcc 4puts -o to save it in the file 4puts. Oh, this should be 4puts.c. Sorry. Then I'll hit enter. So it has compiled. So let me run the code again. So 4puts. Yeah, you can see now it has run, but it did not create any new line. So let me git add, git commit, puts, then git push. You should check now without errors. So start a new test. Yeah, so all checks, no errors. So let's move to task 5 now. So task 5 says write a C program that prints exactly this string with proper grammar, but the outcome is a piece of art, followed by a new line. Now here they said we should use printf. We should not use puts, and our program should return 0. So let's go back to the what's it called? The terminal. Now before we do that, let's quickly do something, because I don't want to be typing the comments over and over and over again. So I'm going to just do something. Let me vim 4puts. You don't need to do this. If you don't want, you can skip this. Well, I don't want to type too much, so I'm going to do this. So what I will do is this. I will copy this include stdio.h. I will copy it all to this place where the comment ends. Right? So I will copy. Then I will exit this one. I will save and exit. Then I will create a new file. The name of the file will be comments. Then I will paste that text I've copied inside here. You don't need to do this if you don't want. It's not necessary, but I want to make my work easier. That's why I'm doing this. Then I will save and exit. Now I can now continue with the task. So let us copy the name of the script, or sorry, the name of the source code. So the name of the source code is 5printf.c. So let me copy it. Now, so this is what I will do. I will just do a little bit of redirection. So I will say cat comment, then greater than, then the name of my source code. So let me explain what I'm trying to do. Remember that I went into 4puts, then I copied the comments, Then I save the comments into this file named comments. Now what I'm trying to achieve with this command is I am trying to insert the text I copied from this place into this place, into this 5printf.c. Like I said, if you don't want to do it, if you want to type it manually, you can type it manually, no problem. But because I don't want to type too much, that's why I'm doing this. So if I hit enter, it has already redirected the contents of this file into this particular file. So if I now do vim, then followed by 5printf.c, and I hit enter, you can see I have those content already in my 5printf.c. So instead of typing this thing all over and over again, I can just redirect it from another file into the file where I want it. So I'll just press I to go into insert mode, then scroll down to the end. Yeah, then I can now go to the next line, then put my main function. So int main, then void, then open a curly brace. Then let's go back to the question and see what they ask us to print. They say we should print this particular string, but we should use printf. We should not use put. So we use the printf function to print this time around. So we say printf, then just like you did the put, your text will be in double quotes. So let's go back to the intranet and copy only the text. So with proper grammar, but outcome is a piece of art. You copy the comma also. Copy, then go back to the terminal, then paste it. Okay, then now they said it must end with a new line. The printf function does not automatically generate a new line for you, so you need to hard code it yourself. You need to put it in yourself. So you put \n for new line, then close the double quotes, then close the bracket, then terminate the statement. After that, you press enter once, then return 0, then terminate this one also. Then that is okay. Then you need to put the last curly brace, the right curly brace at the end. Notice that I am not leaving any extra space and I'm not leaving any extra line. I'm doing that because Betty does not agree with that. You can see I'm also not using the Betty to check my code. You understand? So once you know the rules, right, you don't need to use the Betty. You can just follow the rules in your head. That's exactly what I am doing here. So after doing that, you save and exit. So escape, then ZZ. Then the next thing to do is to compile. Don't make it executable because it's not a script. It's a source file. You don't make source files executable. You compile them. So you say GCC followed by the name of the file. Followed by the name of the file. The name of the file is 5printf.c. So let me copy it from here. Then paste it. Then followed by the flag O to save the output code in another file. The name of the file I want you to save the output code is 5printf. Notice the difference between the two files. This one is ending with .c. This one is not ending with .c. So if I hit enter, it has compiled. So if you hit ls, you will see your executable file 5printf, right? So let us run it. So ./5printf. So you can see it printed out that string with proper grammar, comma. The output is a piece of art. So we are done. Let us add, commit, and push. So git commit -m, then our commit message. You can use the name of the file as a commit message. Then git push. So it has pushed. So let me clear the screen. Then let's go and check our code. So check the code. So we should have all checks with no errors now because we follow all the rules accordingly. So you can see our code checks without even using Betty. So you can see what I'm saying. If you know the rules offhand, you don't really need to disturb yourself, Betty. Now, task 6 says write a code that prints the various types on the computer it is compiled and run on. So these are the instructions. You should produce the exact same output as in the example. That means that what you are doing must be the same thing as the example. Then warnings are allowed. Okay, that means that if your code are having warnings, it's going to, the checker will take it. your program should return 0. You might have to install this package. Now don't worry, I don't think we will need to do this one, but let us continue. So the name of the source code is c6size.c. so I will just copy this, then go to my terminal. Then before I do anything, I will redirect the comments like I did previously. So I will say cat comment greater than the name of the file I want to redirect it to, that is 6size.c. Now, like I said earlier, you don't need to do this. If you find this confusing, you can type the comments in manually, but I don't want to type it manually because it's a waste of time. So I'm going to be doing this. So I will hit enter. So I will now say vim, then the name of my source file. My source file is 6size.c, and I will hit enter. So you can see I already have the comments inside. So I would just go straight to inputting my code. So we are asked to print the sizes of different types. So what they mean by types here is they mean the sizes of different data types that we have in the C programming language. So we have 4 main data types in the C programming language. We have the integer, we have the float. The integer is any whole number, 1 that can either be positive or negative. For example, 1 is an integer, minus 1 is an integer, minus 57 is an integer, 57 is an integer, and so on and so forth. The next one is float. A float is any decimal number. It can either positive or negative. Now the integer on your machine, the space that an integer takes on your memory is on a 64-bit architecture is 4 bytes, right? Your compiler reserves 4 bytes to save an integer on your computer. The same thing goes for a float. A float takes 4 bytes on your computer. The next data type that we have is a char, right? A char is short for character. Character takes 1 byte, and a character can be an alphabet or any symbol. Do you understand? The next one we have is a double. Now a double is like a float, but a double is a decimal number. But the difference between a double and a float is that the double is more accurate than the float. The float the float has 6 places of decimal, right? But the double takes 15 decimal places. So you can see that the decimal places of the double is more than that of the float. So that makes the double like an upgraded, or let's say a more accurate version of the float. They are the same thing, right? But the only difference is in the time, let's say in the instance of accuracy. You understand? The double is more accurate than the float. So this is what we are going to do. There's another one that is called a long. Okay, we also have a long integer and long integer. A long integer is an integer, right? But a long integer takes double the size of an ordinary integer. Remember I said an ordinary integer takes 4 bytes. A long integer takes 8 bytes of memory. A long integer takes double of a long integer, which is 16 bytes. So we are going to print out the sizes of those 5 types. You understand? On our screen. So let me show you how you do that. So I think they said we should only use print. They said we should use print. Okay, they didn't tell us what to use, but we are going to use printf for this one. So what you will do is this. You will just say printf. We're using the printf function to do this. Then you open bracket. Then remember, whatever it is you are going to print must come in double quotes. Matter of fact, let me use this opportunity to explain to you how the printf function operates. Remember I said earlier that a function is a routine that can take one or more arguments and returns a single value. Now, the printf function takes 2 arguments. Now, the first argument it takes is the control string. The control string governs how you want whatever it is you want to print to look like, right? Then the second argument is actually what you want to print. I hope you guys I hope you understand. Let me rephrase that. Printf takes 2 arguments. The first argument it takes is the control string. The second argument it takes is exactly what you want to print. The control string governs how what you want to print looks like. You understand? And the second part is what you want to print. So let us first write the control string for this printf statement. So the control string is always in double quotes. So I'll put quotes. Let's go back to the intranet and see how they want us to print out the output. So they want us to print out the output like this. Size of a char, right? So let's copy this string. So copy, then go back to this, then we paste it, right? So size of a char is, then we put %d, %d. I will explain what this %d is very shortly. %d followed by bytes. Okay, so %d, then followed by a new line, then no, %d, oh no, don't, oh sorry, I've made a mistake here. So I did not include the main function. So let me clear all this first. Yeah, so I'll just do int main, then void, then close my parentheses, close my brackets, then open a left curly brace. Then now I can now start imputing my code. So I'll use the printf function, the printf followed by my control string. Now the control string that we are given from the intranet is size of a char. Then I will paste it, size of a char, then space. I will let me write this line of code first, then I will explain the line. So let me say percentage lu, how is it, okay, there's a space, percentage lu bytes, byte, then the s is in bracket, followed by a new line. I will explain in a bit. Close parenthesis, comma, then size of char, close this parenthesis, close the first parenthesis, then terminate. Now let me quickly explain what I've just done here. Remember I told you that the printf function, it takes two arguments, the control string and what you want to print. Now this part in the double quotes, excluding the comma, is the control string. This part governs how what I want to print looks like. Then this part is actually what I want to print. I want to print out the size of char, Abi. So this is it. So this size of is a function. It takes a particular data type, e.g. char, then it returns the amount of space allocated for this particular data type in the memory. If I finish writing this code now and I run this program, the first answer I'm going to have is going to be size of a char is 1 byte. I will run it so you will understand when I run it, don't worry. Now this percentage lu here is called the format specifier. A format specifier is a placeholder that can hold values in the control string. If you want to print out a number in the control string, you cannot just put the number. Let's say I want to print out size of a char is 5. I cannot just put 5 here, right? Instead of putting 5, I will put a format specifier that can hold the value of 5. Then I'll put the variable holding the value of 5 on the other side. You understand? So it is going to print out size of a char is 5. Even despite the fact that I did not put 5 here, the value of that 5 that is in this place is contained in this percentage lu format specifier or container. Do you understand? Now let's go back to the next line. In the next one, we are asked to print out the size of an integer. So let me first duplicate this line. So what you can do is you can just copy this particular line, right? Just copy it, then press enter once, then on the next line paste it. You understand? Then instead of using char here, is int we want to print for. Just change the char to int. So I will just replace this char with int. Then this char also in the second bracket, in this size of, I will also cancel it, then replace it with int. Replace it with int. So that's all. So you can duplicate this line also again. Copy this line. You can copy it. Then enter once again. You can see I'm not leaving any extra space. You need to be careful about that so that Betty doesn't reject your code. Then go back. The third thing we are asked to print is long int. So you go back again. Change the int you have here, this particular int. Change it to long int. Right? Then also change this one too. Change this one too to long int. Right? So duplicate this line again. Copy. Then paste it again. Then let's see what they ask us to print for the fourth one. They said long int. So you go back and edit it. Instead of long int, change this one to long int. Right? Then also change this one also to long. Then duplicate the line. Copy it again. It's easier like this instead of having to type it one by one. So go to the end of the line, press enter, then paste it again. Then let us see. The last one is float. So this long int, change it to float. FLOAT. Then this one too, this long int that you have here, change it also to float. FLOAT. Okay, so that's all. So hit enter, then return 0, then terminate, then hit enter once, then close the curly brace with the right curly brace. So you can see how my code is. No extra space, no extra line, nothing. Everything is the way it's supposed to be. So the next thing to do is to save and exit. So escape, then capital Z twice. Now we are not done yet. We cannot just compile. They ask us to compile, but they give us the command to use to compile this particular source code. This is what you use. You use this compilation command. So what this compilation command will do is it will create an executable file for a computer that is using 32 bits. This second one will create an executable file for a computer with 64 bits. Now, the sizes of these data types, they are different depending on the computer that you are using. If you are using a computer that is 32 bits, the size of an integer is not going to be 4 bytes, it will be 2 bytes. But on a 64-bit architecture, it is going to be 4 bytes. So what this command does is it will print the sizes for each architecture, one for 32 bits, one for 64 bits. So let us run the one for the 32 bits first. So I paste. Then if I hit enter and I hit ls, you can see it has created an executable for 32 bit, which is this size 32. Also go back to the intranet, copy the second command, the one for 64. Then go to your terminal, then paste it. Then hit enter. If you hit ls, you will see that it has generated the one for 64 also. Sorry, ls in small letters. So you can see I'm having size 64 here. So it has generated the one for 32-bit architecture and 64-bit architecture. Note, to compile the file for this task 6, you must run these two commands. If you do not run it, the code will not check. You understand? So after doing that, the next thing for you to do is add, commit, and push. So the name of the task is 6 size. then I git push. Now we can check the code. So let's check and let's see. Okay, so we are having some errors, 6 and 7. Betty documentation, I guess. Okay, it's not okay. Correct output for the outputs are wrong. Okay, so this is what they got, and this is what is expected. Okay, let us see where the problem is. So this is where the error is. This is what they are expecting from us, right? They are expecting this from us. So if you see my own, I have size of a int here, but in their own they have size of an int. So I need to correct it. So let me go and correct it. So let me clear the screen first. Then let me open the 6 size source code again. So on the line for int, I will change the a to an. So here, this line, I will change that a to an. So an. So that is done. So escape, then save and exit. So I need to recompile again. I'll run those 2 commands again. So let's go back to the intranet. Then you can copy the command, copy it from here. Copy, then go to the terminal, paste it, then run it. So it will delete the first one and create a new one. The first one that was there, to create a new one. Then copy the second one too. Then you paste it also. Then you hit enter. So if you hit ls, you should have those 2 files, size 32 and 64. So let's add commit and push. Then 6 size, then git push. Then let's check the code again. You should check now because we've done everything the way they asked us to do. Yeah, so you can see all checks, no errors. So please, for this particular task, you need to be very careful. Try to follow me step by step so that you don't make any mistakes. So now we are done with the mandatory tasks. So now we are done with the mandatory. It's time for the advanced. So click on this, then click OK. Now for the first advanced task, we are asked to write a script that generates the assembly code, Intel syntax, of a C code and save it in an output file. So they said the C file name should be saved in the variable C file, and the output file should be named the same as the C file, but with the extension .s instead of .c. So let's do that. So let's copy the name of the script from here. The name of the script is 100 Intel. So copy. Then we go back to the terminal. Then we do vim. Sorry, in small letters. Vim. Then we paste 100 Intel. Then we hit enter. Now, so because this is a script, the first line must begin with the shebang. So /bin/bash. Now it should be in small letters. Now the command we need for this is gcc, then we use the -s flag, followed by masm equals Intel, then the name of the source file, which is then C file. Yeah, so that's so after typing this in, you save and exit. Then we make the script executable by doing chmod +x 100 Intel. So if I hit ls, you can see 100 intel is executable. So I can now git add, git commit, then the name of the script 100 intel, then git push. So having done that, I can now check the code. Okay, so we are having one error, so let's see what the details of the error is. So correct output, the output is wrong, so let's check the script again. So let me clear the screen, then vim 100 intel. Okay, oh, I forgot the underscore before the MASN. Okay, so let me add that now. So I for insert underscore. Yeah, so I guess it's fine now. So let me git add, commit and push again. $100 intel. Yeah, so git push. We should not have any errors now. So let's check again. So start a new test. Yeah, so all checks. So last but not the least, for the last task, which is task 8, they said write a C program that prints exactly this string, followed by a new line to the standard error. You are not allowed, now note, not standard output, standard error. You are not allowed to use printf or put, and your program should return 1. And you should also, your code should compile without any warnings. Okay, so the name of the C file is 101quotes.c. So let me copy this, then let me go back to my terminal. Then I'll do, since it's a source code, I need to include comments first. So let me redirect the contents of our comments file into this particular file. So I will say cat comment. Remember what I said, if you don't want to do this, or you don't know how to do it, you can type the comments in manually. Cat comment greater than the name of the source code, which is 101quotes.c. So if I hit enter, so now I will do vim 101quotes.c. So you can see we already have our comments inside already. So I will go into insert mode, then I will impute my code. Now remember, they told us that we should not use printf, we should not use puts. So another thing we can use is we can use the write function to output strings on the screen. So the write function does not belong, you can't find it in this header file. The header file where you can find it is in the uni.std.h. So just change that stdio.h to this. Then the next thing to do now is to input our code. So our main function comes first, int main, then void, which is the return value, which is the argument, is not taking any argument, followed by the curly brace, then followed by the write function. Now this is how you use the write function. The write function is not like the printf function that takes 2 arguments. The write function takes 3 arguments. The first argument is where you want the string you want to print to be printed. They ask us to print it to standard error, so that's the first argument. The second argument is the string you want to print, right? And the third argument is the number of characters that is inside the string that you want to print. The number of characters that is inside the string that you want to print. So let's do that. So we'll now say write open bracket. Now each of the standard input, the standard output, and the standard error files, they have what is called a file descriptor. The file descriptor is a number assigned to this file. Standard input is 0, standard output is 1, standard error is 2. So remember, I said the write function takes 3 arguments. The first place is the file descriptor of where you want to print the screen. I want to print it to standard error, so the file descriptor I'm going to put here will be 2. So you write 2, comma, space. The next thing you want to put is the string you want to print. What is the string I want to print? Let's go back to the intranet. So this is the string I want to print, and that piece of art is useful. Dora Copper 2015-10-19. So I will just copy it from here. Then I'll go back to my intranet. Sorry, to my terminal. You put the string in double quotes. So you paste it. Right? Now remember, they told us that the string should end with a new line. It should end with a new line. So hold on, is this incorrect? The string should end with a new line. Okay, so we need to put a double quote, a new line, sorry. So you put a new line character at the end, then you close the double quotes, right? So now this is what we need to do. We are having 3 double quotes. We need to escape this one in the middle. We need to escape it. So we put an escape and the escape sequence sign in front of this double quote. So we put a backslash. So as you can see, that double quote has been escaped. So after specifying all this, at the end of the string you put a comma to separate it from the third argument. Now the third argument is the number of characters you have in the string. How many characters do you have in the string? Let's count. 1, 2, 3 with the space. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59. We have 59 characters. So that's the last thing that you add, 59. Right? Then you close the bracket. Then terminate the statement. Now remember, they said you should return 1. So instead of returning 0, we are going to return 1 instead of 0. Then terminate the statement. Then you will now close the curly brace. After you have done that, you are through. So save and exit by pressing escape and capital Z twice. Now the next thing for you to do is to compile. So we say GCC followed by the name of the source file is 101 quotes dot, okay, is 101 quotes.c, rather, not this. 101 quotes.c, then minus o, then specify the name of the file where you want your object code to be saved. I would just say 101-quote without the C extension. Then you hit enter. So it has compiled. So let us try to run the code and see what happens. So when you do /101 quote, you can see that that string has been printed on the screen, right? So let us now git add commit and push. So git add dot git commit -m, then 101 quote, right? Then we can now git push. Yeah, so it has pushed. So now we can check the code. So let's check and see if what we have done is correct. Yeah, so all checks. So we are done. So guys, this is how you complete your 0x00 hello world project. So thank you guys for watching my video. I'm sorry about the background noise. Please don't forget to like, comment and subscribe, and I will be seeing you in the next video.